In our last lecture, we discussed the advantages of sklearn at length. What may have stuck with you, though, is that it is a machine learning package. So, you must be tempted to ask if this part of our program is actually dedicated to machine learning. In the very beginning of our data science training, we noted that there are the traditional statistical methods, such as linear regression, logistic regression, and clustering. Then there are methods like neural networks, which are a whole lot more sophisticated, which we called machine learning. In fact, both groups can be considered machine learning methods, and many people do so. To distinguish between them, we can separate them into machine learning and deep learning. In other words, the advanced statistical methods we are covering in these lectures, linear and logistic regressions, often fall under the term machine learning according to numerous sources, and you may feel free to refer to them as ML. All right, great! Some lessons ago, we said that stats models is a great library for learning purposes, but in practice, sklearn is the preferred choice of most professionals. We also hinted that we will learn the theory in stats models and then transfer to sklearn. I believe most of the theory is done. Therefore, to keep our promise, in this section we will do some real sklearning. Here's how this is going to work. First, we will use the same examples as before, but this time employing sklearn. Second, we will not repeat any old theory, so please make sure you have gone through the lessons up until now. Third, stats models fared quite well with Pandas data frames. However, sklearn models work with arrays. Therefore, we'll be compelled to work with NumPy slightly more. Finally, we will learn not only syntax, but also some new concepts made easy by this extraordinary package. Ready? Then hop on to the next lecture. Thanks for watching.